Right. So, Docker, or we need to understand the most important thing is container. So apart from the Docker, what is the most important thing that you have to learn? So if you learn the containers, that's more than enough. So here Docker is just a platform. It is not the actual container. Okay, so if you want to carry the containers from one place to the another place, how ships are most important. In the same manner, if you want to run the containers, okay, if you want to run the containers inside a server, so you need to have a platform, so that is Docker. Apart from this Docker, you are having like containerd. So there are so many containerization platforms. So if you can see containerization platforms, what are the different containerization platforms? These are the different containerization platforms. So if you can see here, so what is a containerization platform? Container platforms, broadly defined as a software solutions that allow you to manage the containerized applications. They provide the capability like automation, orchestration, governance, security, and customization and enterprise support for the container architectures. So what they are going to do here is they are going to carry the containers. So container engines like Docker and Docker Enterprise Edition, which will provide a container runtime environment. So what are the different container runtimes that you need to check? Allow you to create the containers and manage and maintain the containers. Okay. So the first things first, you need to understand what are the different containerization engines, container runtimes. So here you can see different container runtimes. Okay, which application will help you to run the containers? Runtimes in the sense which application will help you to run the containers. So here you can see there are a few like Docker, RKT, Container IO, Containerd, like that you are having so many platforms that will help you to run the containers. So among those containerization platforms or container runtimes, we are going to use Docker. So this is the high level container runtimes, Docker engine. It is one of the thing. And then Podman, it is actually used in RHEL, Red Hat Linux, CRIO. As I already said you, this is also one type of containerization platform like your or else container runtime, like your Docker. And the next one is low level containers run C, C run, run HCS. So these are all we can use. So we can add these container runtimes to your Kubernetes also. So containerd, as I already said you. Okay, so these are all the runtimes. Now, the best runtime, or else if you want to learn about the containerization, the best platform for you is Docker. Okay, so that's it. Apart from this, we are only concentrating on the containers. Why? Because containers are the basic components to run the applications, not the Docker. So if Docker is not there, we can go for the containerd, CRIO, like that. So Docker is the one of the platform that will hold all your containers, where actually your applications will be running. The applications are going to be run inside the containers, not on the Docker. So try to understand, try to reiterate it. So what I am trying to say you here is containers will have the applications. So containers can be run on a Docker. It is not a mandatory thing that all the containers should be running on the Docker. It can run on the multiple platforms. Either they can run on the Docker or containerd or Podman or CRIO, like that. Whatever the platforms that we decide to run the container on that platforms, the containers will be running. So Docker is one of the most widely used containerization platforms. So that's the reason we are going with the Docker. Apart from this, you can go with CRIO. So in some companies, they will be using the Podman. So anything. Okay, so depending on your requirement, you have to choose the runtimes. But my runtime is right now is Docker. So, but my right now my runtime will be Docker. So here, especially apart from the Docker, we are going to learn about the containers. Okay, try to analyze this and fix it in your mind that we are going to run about the or else learn about the containers. So now what will be there inside a container? Inside a container, what is a container? A container is an environment. Okay. Container is an environment. So which will hold the application, which will have the application and its dependencies. Okay, and application related dependencies. So that will be there inside the container. So it will have, for example, I want to run an application inside a Ubuntu environment. So I can create a container with the Ubuntu environment, and that application requires some dependencies. So those dependencies will be available inside a container. So it's a process actually. For example, if I want to, if I open the Google Chrome over here, if I open the Google Chrome, it's an application. It is a process running inside my software. Okay, this is the process which is running inside my software. So this particular software will have multiple tabs, which means that we have multiple processes that are running. So each and every tab will require its own dependency. For example, I want certain graphics related thing. So if that dependency is not there, this particular web page won't be displayed for you. Okay, so to display the web page, you need to have certain dependencies. In the same manner, here the containers are also the processes that are running, which will have an environment to create the applications and to run the application with its dependencies. So if I want to run an application, I need to have a particular environment. I need to have certain dependencies. If I want to run Apache Tomcat web app, so if I want to run the Apache Tomcat web app, definitely I need to have the Java application, which means that Java is a dependency for the Apache Tomcat. And if I want to run certain things like what I can do, Python applications, .py, then I need to have Python installed on my container. Okay, so which means that we need to have the dependencies and as well as the environment to create the, sorry guys, to create the applications. So a container is an environment. First of all, a container is a process in the Docker which will create an environment to run the application and its dependencies. This is what you need to say in the interview whenever anybody asks you about the containers. Can you explain me about the containers? Simply you can say that containers are the process that are running on a container runtime which will have an environment to create the applications and to run the applications with its dependencies. So this is what you need to say. Okay. Again, saying you back, it is a container is a process running on the container runtime like Docker, CRIO, and containerd, which will create an environment to run the application with its dependencies. So this is called as a container. You can give this answer. That will be a perfect one. So after creating the container, we have to run the application. The application will be running. So why containers are required? So I said you that what is a container, but why we require the containers? What is the necessity of that? So first of all, if you see on the on-premises, if you go to before containers, before Dockerization, what we used to have, before Dockerization and all the things, we used to have the on-premises environment, on-prem environment, on-prem in the sense we are within the company. Okay, we have an organization inside the company. We are going to create the servers. So these servers, what are the servers that we have created? Uh, these servers will require more amount of space and as well as more amount of infrastructure related thing and more amount of administrators has to be working. So there is a lot of efforts that we have to put to run the servers. So if when we are running the servers itself, I have purchased a server which is of size somewhere like 16 CPU, 16 CPU and 256 GB of RAM. So this is the server specification which I have purchased, and somewhere around some 4 TB of hard disk size. Okay, So this is a server specification, whatever the physical server that we have purchased. Now, if I want to run any application, for example, I want to run a Java 17 application on this server, I can run it. So the application will be running on the server. But the main problem is, if I am having the second application, app2, which is having the dependency of Java 8. Okay, it is having the dependency of Java 8. So I cannot run that application on this server. Why? Because the dependencies are not satisfied. So first application is running on Java 17 and second application is running on Java 8, which means that two different versions of applications are running on the same instance cannot be possible. So for that reason, what I have to do, I have to purchase another server. Then what is the use of purchasing this much amount of server? So we have a very big server which is of 16 GB, 16 CPU and 256 GB of RAM. So where my first application is only consuming, this application is consuming only 4 CPU and somewhere like 16 GB of RAM. Only it is consuming this much amount of RAM only. And if you see the hard disk space, it is only consuming somewhere like 50 GB of hard disk space. Then what about the remaining resources? If you can see 16 CPU, so 12 CPU is wasted and 240 GB of RAM is wasted and somewhere like 4 TB of storage is wasted. So to overcome this problem, so what are the physical servers that we are facing the problem? To overcome this problem, we are going with the VMware virtualization platform. Okay, VMware or what I can say, Citrix, like that. So what happens here, if you go with this applications, you can divide the physical server into logical servers. But the problem is when you divide this physical server into the logical servers, you can create multiple servers. I am having 16 CPU, 256 GB of RAM server. I can convert that servers into multiple multiple logical servers. Okay, so logical servers where on VM1 I can install RHEL, Red Hat Linux. On VM2 I can install Ubuntu. On VM3 I can run the Windows. On VM4 I can run the somewhere like again going back Ubuntu, like that. So I can install these many number of software, operating systems on the different virtual machines. So whatever the instances that you are seeing in the AWS, these are all the virtual machines which are created on the physical server. So now the point is, so on VM1 I am running RHEL, VM2 I am running Ubuntu, VM3 I am running Windows, VM4 I am running Ubuntu back again. So now if I want to shift one virtual machine from one location to the another location, if I want to shift, yes, we can transfer the virtual machines from one location to the another location, but it is going to take huge amount of time, and as well as it is going to consume a lot of storage space, which means that, so the virtual machines are heavy weighted. So there is a huge amount of space that we need to provide for the virtual machines. So which is a drawback of that. So to overcome this, we are going with the containers. So if you are having a containerization platform or container runtime, you can create the containers. So the containers will use the host operating system. Here the most important term is host operating system. Here it is guest operating system. Okay, the main important thing what you need to understand here is, whenever we are having a server, we have a server hardware. Here you can see, if you think this is the server which I have purchased, physical server that I have purchased, this is a physical server which I have purchased, and this physical server will have the physical hardware like 16 CPU, 256 GB of RAM. That is the hardware which is there. On the top of the hardware, we are going to install the virtualization platform. Either it might be VMware or else Citrix, any virtualization platform. Once we have installed the virtualization platform, we are going to install the virtual machines. So this is VM1, okay, which is of Ubuntu, okay, and then we are having VM2, and then we are having VM3, and then VM4, like that. On the top of that, we are going to install the application. Okay. So here, each and every virtual machine will have its own operating system. So this is app one. app 2, app 3, like this. So here, each and every virtual machine will have its own operating system. To make sure you understand this, let me do one thing. So this is my virtualization platform, which I have installed on my laptop. So currently I am using, what is the operating system? I am using Windows. Okay. So Windows 11 is the operating system. So now, but what I am doing, I am utilizing. So if you can see here, what is the resource consumption? The resource consumption is, look at here. 44% of memory was utilized, which means that 14 GB of RAM is consumed. But when I start the server over here, you can see slowly the RAM consumption will be increased. Previously, we are having 14 GB of RAM. But now what is happening? It should be increased to 14.5. Look at that. The RAM consumption is slowly increasing to 15 GB. You're able to see this. So which means that the virtual machine, whatever the virtual machine that you are running on your system, it is going to consume your resources. So up to now, it has been gone through 16 GB. Okay, so previously it is 14 GB, 2 GB of RAM was consumed. So now the point what you need to understand, so how these applications are running in the back end. So this is the virtualization platform. Now what I can do, I can convert this virtual machine into an image. So I can take a snapshot, or else settings. If you go to the settings, you can convert this into an image and you can send this to another server. But this particular virtual machine, whatever the virtual machines that you are having, this particular virtual machine, if you want to transfer from one server to the another server, it is going to take huge amount of time. So which is going to be very hectic for the system administrators. So to overcome this process, we are going with the containerization. We are going with the containerization. And one more thing that you need to understand here is, for the virtual machine, they will have their own guest operating system. Likewise, just now I have shown you, it's a server operating system, Windows Server 2019, I think. So it's a Windows Server 2019 server. It have its own operating system. But when you come to the containers doesn't have any sort of own operating systems. Okay, it will work with the host OS only. Okay, it is going to create an environment with the operating system, but the point is it doesn't have its own operating system. It will have its own. If at all, if it wants the RAM, or else if it wants the CPU, it will communicate with the host OS. What is meant by host OS? The operating system which has been installed on the server. For example, if I install Windows operating system, so the containers will communicate with the Windows operating system and they will utilize the kernel of the Windows operating system. So containers are lightweighted. So we don't need any sort of operating system should be installed on the containers. So that's the reason the container image size will be 188 MB, 200 MB, or else 150 MB. So you will have very little amount of sizes. Okay, so that's the reason we are going with the containers. So containers are very easy to migrate from one server to the another server, migrate from one environment to the another environment. Here there is a problem with the developers and the system administration people. Developers will develop their code in one type of environment and they will give the code to the system admins. So the system admins will deploy the code in the servers. When they deploy the code in the servers, that deployment, whatever the system administrators is trying to deploy, the server will have a different version. So the application can be working in developer environment. The same application will not be working in the server environment. So to overcome this type of situations, we are going with the containers. Understood about this? Any questions here about the containers? Any questions? Can anybody explain me what we have discussed up to now? Guys, can anybody explain me what we discussed up to now? Something about the Docker containers, what we have discussed. Waiting for your responses.
Sir, I'm having one question like containers also will use a host OS only completely. Suppose I'm creating that container in Windows system. So that container also is going to use my Windows OS only, right?
No,
So if,
no. That is what I am trying to say. Container will not use the container will use the host OS kernel,
kernel, okay.
but not the host OS.
Okay. So containers individually we can have separate OS also. If I'm
Yes,
running the
yes.
content, okay,
Not
okay.
the separate OS, that separate environment. You don't
Environment.
need to install the entire operating system.
Okay, okay. Yeah, got it.
Any questions apart from that? Hello. Yeah, Kamal. You can mute yourself. And I am asking about the remaining rest of the people. I want the confirmation from your end. Do you understand what we have discussed up to now? Hello. Please respond, guys. We don't have all day.
Yes, sir, we are good.
Okay. Okay, fine. Let's get back to the another concept of containers. So this is the reason why we need to have the containers. So after having the containers, so first of all, how to install that Docker. So up to now, whatever we have seen about the containers, what is a container and how the containers can be created. Now let us see how we can install the Docker on the servers. So here I have two servers. Let me log on to the another test server. I just want to show you how you are going to install the Docker on the servers. So which type of okay, fine. So Ubuntu platform. Let me start it. And I am going to install another Windows operating system also. So to make sure that you will understand how to install Docker on Windows, Docker underscore Windows. I'll go with Windows and then T2 so micro is not sufficient. Go for T2 medium. It's a chargeable. So my request is to delete the server once you have completed the session. Okay. And I will go with AWS default. Launch the instance. So I have deployed the Windows instance. Let it come. So we have an Ubuntu server. Let me log on to the Ubuntu server first. Okay. So this is my Ubuntu server. I just need to check whether the Docker is there or not to make sure that you see it. What I can do here is okay. So sudo su hyphen docker ps. Okay, Docker is there. Okay, I will tell you how to install it in the Linux machine in the next session. But as of now, already both the missions are having the Docker, so I don't want to remove them. These are necessary for me for the classes. We'll see how to run that. I will show you. So let me log on to the Windows mission. So as of now, you are all using the Windows. So now what I can do, connect RDP client as it is a Windows operating system. Download the remote desktop file. You can use it. You can use the same way in your Windows computer also. So get the password, upload the private key file. Don't worry, I am trying to log on to the Windows operating system. That's it. So this is your Windows system, which is nothing but your computer. Okay. Yes. So from here you can see this is my Windows system. Okay, let it come. So now what I will do here is I will go back to the Docker installation, Docker install on Windows. Okay, Docker install on Windows. What you can do, you can download this Windows file, or else let me go back to, yeah. Docker install Windows. Okay, so you can download it. It has been downloaded. Then what you can do, you can run the installer. Hold on. It is taking this much of time. Yeah, it has been downloaded. Okay, so it is going for the configuration. So let it come. So this is how you have to install your Docker on your Windows. Just download the Docker from the Google and install it. So once it is installed, here the Docker desktop should be running. So after running the Docker desktop, then you can go ahead into the configuration of containers. How to go for the configuration of the containers, that we will see in the next session. From next session onwards, your configurations will be started. So everything will be a practical oriented sessions. So today is the second day of your demo. Tomorrow will be the last day of your demo sessions. Once the demo sessions are completed, then so like today and tomorrow we will complete the demo sessions, and from day after tomorrow you will be having the session at 6 o'clock and the demo sessions. And so those who has paid the fees, they will have the new link. Okay, so one more thing that I want to ask you here is, please provide your mobile number and proper mobile number in the chat box. Please provide your proper mobile number in the chat box. You can send me a direct message, guys. Please share your mobile numbers. I think I have two more candidates. So Kamal, Venkateshwar Rao, and Nirmit. So thanks for that. And I want Karthik. Okay, no problem. Those who didn't give, I don't have any problem with that. So that's it. This is how you are going to create the Docker on your laptop. You can easily create it. So the next one is what I can do here.
Hi, sorry for this. I cannot
Right.
see your screen.
Screen is not shared.
I just stopped it. I just stopped it. Okay, fine. Now I hope you are able to see it. So this is how we can go for the Docker containerization platform. I just show you, I have a container Docker desktop that is running on my system, on my Windows system. You can also install that. And after installing, so what you can do here is you can go to the command prompt and just give the command docker ps. See that I am getting the responses from the Docker engine. So if I stop the Docker engine, what is going to happen? I just close the Docker engine, and as well as I'm going to quit the Docker desktop. I'm going to quit the Docker desktop. See. So turning off the Docker engine. So the Docker engine got turned off. When I go for Docker PS, look at there, I'm getting the error. So what is the error? Docker engine is not running. The system cannot find the file specified. So if the Docker engine is not running, you are unable to get the response. So if I go for Docker images, I will not get any response until unless you have the Docker engine running, then only the responses will be coming out. So if I go with the Docker desktop over here again, once the application is started, then only we can run the containers. Let it come. So what about this? Okay, the server will be restarted. We have to wait for some time. Now once see here, this is my Windows Docker. So I can go with command line. So I will go with the Docker PS. So now I am able to execute the commands. So what is the what is the concept here? Until unless you run the Docker engine, your application won't be running. So first of all, how to install the Docker and what is the necessity of. So in this session, we have learned about these things. In tomorrow's session, we will be going with the containers and creation of containers, creation of the images. Tomorrow's session will be a little prolonged session. So that's it from my end. So if you have any further question, you can ask me now. Any questions? You can ask me now. No questions?
No.
I just see here my Docker server is up and running. So after going ahead, I just want to show you whether the Docker desktop is running or not. So let me show. Okay. So here you can go to the start menu and you can type Docker desktop. Docker desktop. So until unless the Docker desktop is running, you cannot run the server. So here you can see Docker PS. Okay. So it is saying that there is an error. Look at that. Still accept it. See, there is an error. So again, I will give Docker PS. Use the recommended settings and finish. Again, see here. The Docker desktop is about to start. So when we give Docker PS, this time it should come. Look at that in the background. Continue without signing in. Keep the survey. So now the Docker engine is starting. So hold on. Okay. So this is how you can install the Docker. Okay. So WSL error that I will check out that, but as of now, this is how you can install the Docker on your Windows machine. Please install it. This will be very helpful for you when we go ahead into the concepts. Okay. So that's it from my end. Have a nice day and delete the server. Okay. Have a nice day. We'll meet in the next session. Bye guys.